Hey everyone, welcome back to Chapter 1, Section 2. Here we're going to be identifying multiple transformations. So the first example says the graph f of x equals absolute value of x is transformed to create g of x equals negative 2 times f of x. Identify the function type, its transformations, and write the new function. So the function type, I read it as absolute value of x. You're going to say absolute value. Okay, and then they threw out two transformations. I have a negative, and then I have the 2. So the negative is going to do what? In the last videos, I outlined what negatives on the outside do. So by definition, if you see a negative on the outside, it's going to reflect it on the x-axis. Alright, so now that we've identified what that negative is doing, let's identify what that 2 is doing. So you're multiplying a 2 on the outside. So by definition, when you multiply a number on the outside, it's either going to vertically stretch or vertically compress. If it's bigger than 1, it'll vertically stretch. If it's smaller than 1, it'll vertically compress. 2 is bigger than 1, so it'll vertically stretch. And so we just point out that it's a vertical stretch by a factor of 2. If it's vertical stretch or compression, you just use the number on the outside. Remember, if it's horizontal stretch or compression, that number's on the inside and you flip it. So if the definitions don't really work for you, let's look at a visual representation. I'll just scroll over here and I'll pull up a picture of the graph. Here we can see in red that the original is graphed square root of x, and then the next thing I did was I graphed the 2 on the outside. So you see it vertically stretches it gets skinnier, and then I put the negative so you see it flips over the x-axis. So there's your visual representation. You can always check that. You can always check the graph if you need any help. And well, we just need to write our new function, and I technically already graphed that. See, I put the negative 2 on the outside. See how the negative 2 is in the outside of f of x? So just throw a negative 2 on the outside of whatever is given for f of x. So yeah, I just say we usually use like g or some other letter, h, I don't know, just not f again. So g of x equals negative 2 times the absolute value of x. And that's all there is to say about number 1. Example 2, the graph of the cube root of x is transformed to create g of x equals, and then you have f times negative 1/3 of x. Identify the function type, its transformations, and write the new function. Alright, so what kind of function do we have? I read it as the cube root of x. That's your function, cube root. So now we just need to identify our transformations. If a negative on the outside reflected on the x-axis, what do you think a negative on the inside is going to do? It'll reflect it on the y-axis. And then if you have a 1/3 on the inside, if you're multiplying a number on the inside, it's no longer vertical stretch or vertical compression. It's either horizontal stretch or horizontal compression. So 1/3 is going to make that graph get wider. So if I'm using the horizontal language, I'm pulling on it from the sides to make it wider. So I'm going to say this 1/3 is going to be a horizontal stretch of a factor of 3. You have to flip that number. Okay, and then so what I like to do now is just show you the graph to help justify what we wrote down. So let's look at the picture over here. The first thing I did was I graphed the original cube root of x, and then the negative on the inside should make it look like it flipped across the y-axis, and so that means it looks like it should flip sideways. So from green to purple, it should look like a perfect mirror image if you drew the mirror along the y-axis, which it does. And then the 1/3 should make it look like you pulled on it from the sides. And it does look skinnier like we pulled on it from the side. So the picture justifies our answer. To write the new function, again, as I was explaining this, I ended up writing the new function. You just put the negative 1/3 on the inside since it was written on the inside. So you just say, g of x equals, and so you had f of negative 1/3 x. So you're going to say the cube root of negative 1/3 x. All that's under the cube root symbol to represent it's on the inside. And that's all there is to say about number 2. So the next couple of examples, I'm giving you the parent function, and then I just want you to identify the function type and the 4 transformations. All right? I'm never going to give you a question with more than 4 answers, I don't think. So x to the third is transformed into the graph of h of x equals negative 4 times x minus 5 to the third power plus 1. Identify the function type and 4 transformations. So if you have x to the third power, what are you doing? You are cubing it. So you have a cubic graph. So now that I know it's a cubic function, let's just break it down term by term. I have a negative on the outside. If you have a negative on the outside, we just did an example like that before. Negatives on the outside reflect on the x-axis, so that's what you'll write in the first blank. And then we have a 4 on the outside. I know it's on the outside because, look, it's not on the inside of the parentheses where the cube is going. So if you have a number bigger than 1 multiplying on the outside, it'll be a vertical stretch like we did in the first example. So I'm going to say that the 4 is a vertical stretch by a factor of 4. And I'll write that in the second blank right there. So now I have this minus 5 on the inside. And so remember, inside actions go backwards of what you might think. So I'm going to say, or we're going to say, that the minus 5 is not going to make it go down 5, and it's not going to make it go left 5. It's going to make it go right 5 units. So I wrote translate right 5 units. The last one I'll do in green, so I hope you're able to see it. Plus 1. What is that plus 1 doing? It's on the outside. Outside goes normal like you would expect it, so it's going to move it up 1 unit. And so there are my 4 transformations. So at this point, I'm going to show you the graph to justify my answer. So I'll go over here and I'll pull up the picture of the graph. So the first thing I do is I graph the original x to the third, then I graph the negative that was on the outside. So it should look like it's flipping over the x-axis. So it goes like this, moving up from left to right, and if it flips over the axis, then it's moving down from left to right, so that's good. Then the 4 we said was a vertical stretch, so it should look like I'm pulling from the top and bottom to make it skinnier, which it does. And then I graphed the x minus 5, so it should look like it moved right 5 units, which it does. And then the plus 1 should make it look like it shifted up 1 unit, which it does. So we're good. The last example I'm going to do is I give you 4 to the power of x, and it's transformed into the graph negative 8 to the power of x minus 3 plus 1. Identify the function type and 4 transformations. So what do we have here? What kind of function is this? If x is your exponent, doesn't matter what the base is, just matters what the exponent is. And if x is the exponent, then guess what? You have an exponential function. That's your function type. The next thing to identify is I told you have 4 transformations. So I see that I have a negative here, and I see I have an 8 now, and so that is going to be something, and the minus 3, and then the plus 1, all right? So, let's change things up just so we don't have 2 plus 1s on the end. We're going to change this plus 1 to say minus 1. Yay, real original, right? All right, so minus 1 now. Okay, let's start with the outmost transformation first. You have a negative on the outside, so we must reflect across the x-axis. Only negatives on the inside make it reflect across the y-axis. So that 8, what am I going to do with that 8? I had a 4 originally, and then it moved to an 8. So if you went from a 4 to an 8, I multiplied it by 2, didn't I? 4 times 2 equals 8. So if I multiply it by 2, and that number is on the outside, because it's not part of the exponent, that is a vertical stretch by a factor of 8. Sorry, not 8, 2. You multiplied it by 2. Vertical stretch by a factor of 2. Okay, so I hope that one made sense. The minus 3, where is that? Is that on the outside or the inside? It's on the inside. So if it's on the inside, it's going to make it move left or right, not up or down. And so if it's on the inside, minus goes left, plus goes right. No. Minus goes right, plus goes left. Remember, it's opposite of what your intuition might tell you, like what I just did. So minus 3 is going to make it go right 3 units. So write down that it translated. Use translation for moving up, down, left, or right. Translate right 3 units. And then what is the minus 1 doing now? Remember, I changed it from a plus 1 to a minus 1. So what's the minus 1 doing? Instead of going up 1 unit, it's going to go down 1 unit. Plussing or minusing on the outside goes up or down. Plus goes up, minus goes down. So I'll say translate down 1 unit. And so now I've identified all the transformations. And so guess what I'm going to do now? I'm going to show you the graph to support what we just said. So the original was 4 to the power of x. When I graph 8 to the power of x, it should look a little bit skinnier. Like if you vertically stretch it by a factor of 2, it should look like you pulled on it from top and bottom to make it a little bit skinnier. And it does look a little bit skinnier. That's why it's kind of more on the inside. Then the negative should make it look like it reflected over the x-axis, which it did. The minus 3 should make it look like it moved right 3. Looks like it went to the right 3 units. And then the plus 1, I forgot we changed that to a minus 1, so let me fix this picture. Okay, so here's the new photo. The original had gone up 1. You see this one going clearly down 1. So the graph does support everything I said. So that's going to draw the video to a close. Thanks for watching, and goodbye.